Mark Honger. This is a video that teaches you about what's called a binary search. You will have already looked at the linear search. That's going down the line, searching for what you want. So if I had a list of a million things, the linear search basically says start at number one, move the pointer to number one, and compare them. Is that the one I'm looking for? No. Then plus the pointer by one, and then compare the two. Is that the one I'm looking for? No. And then move plus one and plus one and plus one until you find the one you're looking for. So that's working down the line, and it's called a linear search. Now, if the list is a million things, that takes ages. So they decided that in computers with so much to search for, things like Google, you need quicker instructions for finding things. So here's the binary search. Binary means about sort of dividing in two and working in twos. And so this is all about finding the middle of the list, and then quickly working out whether it's going to be in the top half or the bottom half, and then dividing, getting rid of the half of the list that you don't need. So in this case, it would find half. So it would say this one from 1 to 7. There are 7 spaces on here. So the sum that we use for this is to say that we do 1 plus 7, which is 8, divided by 2, which is 4. So what we would do is we'd immediately jump to halfway down the list, even if it was a million. And we say, are they the same? Is that the one I'm finding? No. So if I haven't found it yet, if I found it, great. But if I haven't found it in the middle, then I just say, is what I'm looking for greater than that middle of this list? And because it's greater than the middle of the list, I can now delete or not bother checking the whole first half of the list. Now I've got a new list, it's a shorter list, and I run the pattern again. So find halfway. So 1 plus 3 is 4 divided by 2. It means that the middle of the list, of the new list, is place number 2. So now I can say, is this thing I'm looking for, is that one greater than the one that I'm looking for? And it is. So that therefore I can, because it is this time, I would actually delete the top half of my new short list, like that. And then I've got a new list, which is just one thing, and I would find the middle of it, which of course happens there. And then I make the comparison, and in just 3 questions, I have cut my list down and found what I'm looking for really quickly. And it also finds it almost in 7 or 8 questions, even if the list is a million long. So let's look at that in Scratch, okay? So in Scratch, we've got this program I wrote, and this program for searching now has a button called binary search, and it resets all of those settings that I'm using for the top of the list and the bottom of the list and the middle of the list. It resets all that, and then it runs a binary search. All right, so when it runs a binary search, it asks somebody what number they want to find. And remember, of course, we have to have sorted it. You'll notice that search, this binary search, only works if everything's in order. So we've got an answer for what the number they want to find, and it keeps repeating the finding the middle and the divide until found is true. Or it's done so many divides that it's the same length as the list, and therefore it can't have found it. So the 2 jobs are find the middle and then either find or divide the list. So let's look at find the middle. You can see here's that sum that I just said. The middle of the list setting gets changed every time to a rounded number of the top of the list, which is 1, plus the list bottom, which is 10, that's 11, divided by 2, but it's a rounded number up, so divided by 2, 11 divided by 2 is 5.5. You don't want that because that's not a place on my list, so we round it up and it becomes number 6. So that's the middle of the list. After it's found the middle of the list over here, then the next broadcast is that found or divide the list. So if the item in that new middle of the list is the one I'm looking for, then found equals true, well done, you found it. Else, if it isn't, we need an else here, if else, then inside that else we have if the number defined is greater than the middle, then we've got a new list. So we end up with resetting the list top to where the middle was. All right, so in this case, let's just have a look. If I'm looking for something that's in place number 7, I'm looking for the number 25, then it would compare 24, the middle of the list, with 25, and it would say, well, the 25 that I'm looking for is greater than the 24 that's in the middle of the list. So now I'm going to redo my new list, my short list, by saying that the list top is now not 24. It's now place 6. All right. So because place 6 is my middle of the list, and so now the list top is going to start there and go to the bottom of number 10. So now I've got half a list to search, and because I know it's in the bottom half. If it's not, so you've got an if else. So if the number is not greater than the middle of the list, it does this opposite thing, and it sets the bottom of the list to where that middle is. So the bottom of the list now, so it's now going to go from 1 down to 24, or 1 to place 1 to place 6. So this one is doing the half, the top half, and that one there is doing the bottom half because it's greater than the middle. So I hope that made some sense, and you can see that going on there. It's resetting these settings to where to start, and that's the main task of the binary search, to find the middle and divide. So I hope that made some sense, and I'll see you in class. Kia ora. That's the binary search.